Good evening, YouTube. Today, I'm going to talk about one of the first strategies that I see as being very important to addressing the issue of global climate change. And it might seem like a small one, but it's very important because it's something that doesn't require a lot of capital to do or a lot of money. And it's something that can be done to improve landscapes everywhere so that they sequester carbon. And when we talk about reversing global warming, the primary thing we need to be addressing is sequestering carbon, and then we need to be, uh, reducing emissions. Because fact is, even if we are able to get most of our emissions under control, there is still a pretty big legacy load of carbon dioxide in the atmosphere that is going to do a lot of damage to the climate. And according to Bill McKibben, who founded 350.org, the safe number that we need to get back to is 350 parts per million of CO2 in the atmosphere. Uh, some would argue that it needs to be even lower than that. Pre-industrial levels were closer to 250. So if we could, over time, get back to 250, that would probably be excellent. We would probably have a much better climate, and we would restore a lot of our degraded areas back to their original productive capacities in the process. Now, to capture carbon and sequester carbon, you need water. And where, things grow, plants grow where water flows. And the water that is escaping us for the most part is rainwater. And the biggest reason why water seems to be escaping us is because our different economic systems of managing agricultural infrastructure and irrigation, particularly in the highly developed, high-tech agricultural countries like the United States, and really high-tech regions like California, where we've invested fortunes in developing new types of water infrastructure and irrigation infrastructure, have really cast to the wayside a lot of the ancient knowledge that was passed down from indigenous peoples and sustainable farmers around the world. And because of that, the amount of gain that you get from rainwater is thought to be negligible. And mostly this is because of business models that don't take into account a one-time investment paying itself off over 5 years, 10 years, 20 years, and instead of doing all these steps to recontour their landforms and capture as much rainwater as possible, commercial agricultural interests would much rather lay down plastic drip tubing and use as little water as possible from their irrigation pumps. Never mind the fact that when it rains, they might lose most of their rainwater to runoff. This is particularly apparent in places like Ventura County, where new avocado orchards are going in all the time, and a lot of the new orchard plantings have the rows of trees going vertical up and down the hill across the contour lines, so that when it rains, the water falls in between the furrows of the trees, the large rows between where the trees are, and drains right down the hillside. And that's not a very good strategy for conserving what is free water. And when we talk about these strategies for harvesting rainwater, and most of the strategies that come from the amalgamation that is permaculture, we're talking about strategies that are first and foremost designed to mitigate entropy. So you have a free resource, rainwater, falling from the sky. You want to dig a swale being a ditch that's on contour, so that when that rain comes in, it falls in there and it captures it. And really, this will, you see swales can have a lot of different forms. This is a swale somewhere out in Wyoming, and you can see the area on the downhill side of this swale, because I'm guessing, if you pan out some more going this way further, will be a little more downhill than this raised ridge here. But you can already see the effect of the water infiltration causing this whole thing to green up. And when they have those flash floods, uh, those prairie thunderstorms, this is going to be a very huge water harvesting feature. It's probably fill up. Now, where swales were really originally used, and this is a picture of Jack Spurko, very prominent and I would say even leading permaculture educator here in the States. He's got a lot of stuff online. You can watch his permaculture videos. A very good place to get acquainted with permaculture design techniques. But he shows how swales were originally really used in highland areas where there's a bit of a slope, and you can see the grade here. And if you don't put this swale in, when it rains, that water is going to run all the way downhill. It's going to carry silts. It's going to carry deposits, and it's going to lose all of its energy, and you'll lose access to that water. So, you know, history has shown us, and if you look at the book Dirt: The Erosion of Civilizations, almost all original centers of civilization, of agriculture, happened in the rainy highland areas like this, whether it's Mesopotamia or northern China. The original people who first started domesticating crops and settling down, living an agricultural lifestyle, set themselves to farming regions like this. But because they would just plow these lands where there's a slope like this without putting in swales like this to capture the rainwater and slow it down, they would denude some of these highland sloped areas in as little as 20 years, or a couple hundred years or whatever. There were places in China in the book where he talks about new land being denuded in less than 20 years, and this is in the what's called the Shaanxi region of northern China, the headwaters for the Great Yellow River. And since the very first Chinese civilizations denuded these landscapes by plowing them with their plows and tilling them up, the Yellow River, well, they changed the name from the Great River to the Yellow River because so much of the silt and sediment from those upland regions eroded off, entered into the Great River, and turned it yellow. And that's why it's the Yellow River now. So, this is something that different peoples figured out a long time ago would be a great way to arrest the erosion inherent with rain and prevent the loss of all that silt and sediment and nutrient from going downhill into the rivers and making messy floods. Because when you put it into this swale, the water infiltrates, and you have a subsurface flow rather than a flow above ground. And you know what makes the swale incredibly important is that, the aspect of the swale that's incredibly important is that you fill it up with mulch, because if you don't put mulch into your swale, you're going to quickly discover a problem with salinity. So whenever water comes down from the sky and it comes down here, like down this slope, it's carrying with it a lot of dissolved salts, a lot of calcium, sodium, chlorides, other dissolved ions that leach out of the rocks and the minerals with it. And then if you put it into a situation where it's entering your soil profile and then your plants are uptaking it, it's always possible for salts that were brought in down to the lower levels to be brought back up. So you deal with this problem by putting in organic matter. And it's been found that organic matter, organic mulches here, have the ability to capture and sequester these different salts, prevent them from doing damage to your plants. And, in school, we were always taught that you deal with salt problems by adding more water. You add more water to flush the salts lower and lower and lower until the salts have gone down into your aquifer and they've removed from your system through deep percolation. However, end the end result of that is that you might put so much salts in that you start to develop a salt crust on the top of your soil. And this is the problem that destroyed the ancient Mesopotamian cultures. The very first civilizations in the Fertile Crescent to grow barley, to grow wheat, to grow some of our first cereal crops were undone and destroyed by salinity because they added all of this irrigation water from their rivers, from their river meltwater in the summer, and didn't do anything to check the increasing salinity. So adding mulch is important. And this is where we really get into how swales in particular, and the way they capture rainwater can help us to capture carbon, sequester carbon, and regreen deserts. This is a picture from a project in Wadi Rum in Jordan, run by the illustrious, famous Geoff Lawton, one of the world's foremost permaculture educators. And he's really proved here that this system, if it works in Jordan, Wadi Rum, where it's below sea level, they get less than an inch of rain a year, and it's really, really, really hot. 110, 120 degrees in the summer. It can work anywhere. And what happens when you do this is you store water in your soil, and you store water in your carbon layer, in this mulch layer. Incredibly important, because again it helps to dilute out those salts, and it also stores up the water that you might otherwise lose to deep percolation, holds it in place so that your trees can uptake it over the growing season. And now that you have trees and you have shade, you're changing the whole microclimate of this region, because you're putting shade on the ground, preventing the ground from losing more water to evaporation. And the trees are also producing biomass every year. That biomass goes back onto the ground and prevents the damage caused to more plant life by the accumulation of salts, because that biomass breaks down into soil organic matter. That soil organic matter supports the growth of all of your bacteria, fungi, protozoa, nematodes, all that soil organic life that helps to sequester and tie up the excess salts that could otherwise damage your plants in a very dry, highly evaporative climate like a desert. And then you're also beginning the process of seeding clouds. Now, trees, pretty much all plants, when they uptake and use water, they transpire water, and the small microscopic beads of water that they transpire through their leaves contain more than just water. They also contain, if I remember correctly, they're called phytoterpenes, and different organic compounds that serve as condensation nuclei for forming water droplets in the upper atmosphere. Trees essentially seed clouds. Now, in a small thing like this, small desert oasis, you might not see that effect, but if we can do this across large enough tracts of land, there's no doubt that enough trees will create enough of a critical mass at some point to begin to seed their own climatic patterns. And where we see this happening in reverse by deduction is in the Amazon rainforest. Now, parts of southern Brazil, specifically Sao Paulo, you can watch a video on Vice about this, are experiencing tremendous droughts. And the original source, the cause of these droughts, is deforestation in the Amazon north of Sao Paulo. Because as large swaths of the Amazon have been deforested, denuded, turned into soybean fields, a lot of the transpiration of those of that jungle and rainforest is lost, and that transpiration was the source of the clouds and the moisture and the humidity that rained down on Sao Paulo. And that's why there are such extreme droughts happening in southern parts of Brazil. It's pretty catastrophic from the reporting I've seen on Vice. So, it holds true that if we deforest areas, we can cause droughts. If we reforest areas, particularly these deserts with, these sorts of systems, these gravity-fed systems. I mean, a swale is a gravity-fed system. This is passive. There's no energy required to operate this besides going out there with your tractor, with your backhoe, and digging these out. But once they're in there permanently. They're passively harvesting the rainwater, and they're creating these little islands of improved microclimates. And if we improve enough microclimates on a large scale, it contributes to the transformation of the global climate. So, you could say this is a long shot. You could say that, this is unrealistic to think that we can transform enough of the arid drylands, enough of the deserts, enough of the places like the Mojave Desert where I live now to make a difference. But I think that's really limiting, because this doesn't take much education or knowledge to understand. or to apply. It doesn't take constant reinvestment. I mean, the permaculture school of thought and systems will try and turn these into productive agroecological systems by turning this tree right here into a fruit tree, and some mixture of fruit trees and nitrogen fixing trees and all that. But the problem as it exists with current agricultural economics is that agricultural economics and our markets are designed around systems for highly, super dense, intensive agriculture, where instead of you take this land, if you want to farm it, you'd put like, 100 avocado trees on here in a line. And that way you get the economies of scale of, oh, you only have to pay your fruit picker $15 an hour, and he doesn't waste any time going between tree to tree to tree picking all the fruit. Versus if you design this for ecological restoration, the gap between your trees, your fruit picker is probably going to be able to pick one tree and then have to spend 15 minutes walking to the next fruit tree because all the trees in between them are the hardy nitrogen fixing legume desert trees. So while this is a very good strategy for survival, for subsistence agriculture, particularly for peoples in developing countries, it's harder to make this into a model for producing food for export or for commercial production, so long as the intensive and more or less sustainable models are rewarded by the marketplace. That said, if you look at this primarily from the perspective of ecological restoration, of, we're going to put the hardiest nitrogen fixing desert legume pioneer trees, we're going to put mesquites, we're going to put acacias, we're going to put leucanas, we're going to put, you know, moringa in more arid tropical climates. We're going to put I can't think of any more. I guess red buds in certain climates, in maybe in the prairies where there's a little more rain, like places where there's 15 inches of rain or so. This can absolutely thrive with very little maintenance beyond the initial investment of, you got a work crew out there, you got your guys in your conservation corps with their tractor, dig the swale out, lay it out, fill it up with mulch, till in biochar, if we can get it, because that's probably the best, most concentrated form of soil organic carbon that goes right into the soil, is immediately active, and then just wait for it to rain. As it rains, the system gets better. Come back once every 2 or 3 years to prune these trees, chop them up, and then put that biomass back into the swale. And the battery that stores the water grows larger and larger. And then over time, the space in between these swales will develop more trees, more plant life, more growing material. This is how we can begin to take, these parts of the world that are desert drylands that have uh, very low albedo. They're absorbing a lot of heat into our planetary system, and then cover them up with vegetation so that instead of absorbing heat, they're repelling heat, and instead of concentrating salts and all these other dissolved solids that kill life, they're transpiring water and phytoterpenes into the atmosphere and seeding new clouds, and basically making the planet a little more humid and a little more hospitable. So this is one of the most important, one of the important baselines. And part of the reason I went into this first is because a lot of the other things that I've seen, a lot of the other technologies that can be plugged into this synergistically, need this as a base point, because this is a strategy for maximum leverage of our efforts to get the most out of the water we already have, and to get even more of whatever water we can apply, because it's rain that comes up here. But what if we can find a way to supplement this with some kind of irrigation? You just add the water up top, and same thing happens. No need for drip, no need for sprinklers or pressure or pump. You could just let it flood, as long as you have this mulch layer here to absorb up and complex out those salts. Flood irrigation is more effective than it gets credit for. So I hope that this has been a valuable and informative video. This has informed some of your ideas and sown some seeds in your mind about how we can approach just the conversation about fixing climate change and carbon sequestration. And really, we got to start small and then grow big, because this affects the microclimate of a small area. But over time, as we replicate it, I mean, look at this picture here. This is in Iran, probably it's just part of the rainy season, but Iran, for the most part, is a very dry, arid region. And you can see swales at work on this highland, and they just started to plant trees. I'll put a link in the article, because the article that discusses this has a lot more interesting information about some other gravity-fed passive water manipulation systems, gabions, check dams, so on and so forth. Fascinating stuff. I'll have to go over it in another video. I hope this has been informative and you've enjoyed it. West Coast.